Proving triangles similarity by side, 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 and side angle side. Now this is triangle similarity, not congruence. Okay, triangle similarity. So by side, 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 we have, I'm going to take this off the thing right there and say, if this is on page 436, side, 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 if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So if this side matches up with this side and they're proportional, and these two sides are proportional, and these two sides are proportional, that means the triangles are similar. Okay, that's side, side, side similarity theorem. It's not saying that the sides are congruent. It means the sides are going to be proportional. The sides are proportional. Okay, side lengths are proportional, not congruent. Okay, if the triangles are congruent by side, 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 well, if they're congruent, automatically you know they're going to be similar. Okay, so this is side, side, side for similarity. And then you also have side, angle, side. This is side, angle, side. So in this case, the sides, if an angle in one triangle is congruent to the angle in the second triangle, and the lengths of the sides, including those angles, are proportional, then the triangles are similar. So in this case, there we have. So this angle and this angle are congruent to each other. They're equal. That means these two sides are going to be proportional, as well as this side and this side. That side and that side are proportional to this side and this side. Okay, so that's the side angle side similarity theorem. Okay, so now that you know that, we just did this. This is for similarity theorem. SAS. SSS similarity theorem, all the sides are proportional. And we did this the other day, the angles are congruent. So two sets of angles. Here's one set of angles that are congruent, and the second set of angles are congruent. That means the triangles are similar. Similar. Sides are proportional. In this case, the angles are congruent. These two angles are congruent. The sides are proportional. There we go. For similarity, you only have these three: AA, SSS, and SAS. Let's start with some of the problems. Question numero 3. Number 3, let me put this back up on this holder. Boom. Okay, boom. So we have, that was for side, side, side. Question numero 3. It says, determine whether JKL or triangle JKL or triangle RST is going to be similar to triangle ABC. So if they're going to be similar, then here the long side matches up with the long side, long side. So long side, long side, long side, they're all matching up, all drawn the same way. Shortest side, shortest side, shortest side, matched up. And that would be middle side, middle side, middle length, middle length, middle. All right. Let's go 12 over 11. Is 12 over 11 equal to 7 over 6 equal to 8 over 7? If that's a true statement, that means these two triangles are similar. 12 over 7, nope. Nope, they're not congruent. That means these triangles, since this is not true, that means these are not similar. How about these two? 12 is to 6. 12 is to 6. Is it similar to 7 is to 3.5? Is it similar to 8 to 4, 4? So that's a 2, that's a 2, yep, that's correct. Yes, that is correct. So therefore, triangle ABC is similar to triangle A down this spot R, made of B B's right here. That's an S. C's here to T. Triangle ABC is similar to triangle RST. This triangle, ABC, is similar to triangle RST. It's not similar to that one. Okay. Question numero 5. Question 5. Find the value of Z. Find the value of X that makes this triangle similar to this triangle. Find the value of X. So DEF is similar to triangle XYZ. Okay, so these are matched up, oriented the same way. 5 matches up with 10. 5 is to 10 as 2x minus 1 is to 14. There you go. So that's one way of doing it. You could also say 5 is to 10. 5 is to 10 as 11 is to 5x minus 5x plus 2. You do it that way. So you can solve it this way, or you can solve it that way. I don't care which one you do. 5 times 14. The rest of this is algebra. 5 times 14 divided by 10 equals 7. 7 equals 2x minus 1. Add 1 to both sides. Divide by 2. You get 4. X is 4. Question 5. X is 4. What about this way? In this case, x in the denominator, so you're going to have to cross multiply. 5 times 5x plus 2 equals 10 times 11. 110, 25x plus 10. Subtract 10. Divide by 25 on both sides. X is 4. So both cases you get x is 4. In this case you get x equals 4. In that case you also get x equals 4. Either way, it works. Number 10. Number 10. Ooh, number 10, when you look in the book, number 10, they're not oriented the same way. So I took number 10 looks like this. I took this and redrew it so it's oriented. Now they're oriented the same way. So when you look at question 10 in the book, they're not oriented the same way. I just made it easier because it's oriented the same way. Okay? A is to B as 18 is to 24. Oh, we have to determine whether they're similar or not. Well, A over B, are they equal to 8 over 10? Are they equal to 18 over 24? Is this a true statement? 8 over 10 is 0.8. 18 divided by 24 is 0.75. Are they equal? Nope. Since these are not equal, that means these are not similar. Nope. Not similar. Not similar. Bam. Next. Question numbers 15th. Turns the page. Question 15. Show that the triangles are similar and write a similarity statement. Okay, explain your reasoning. So again, question 15. These triangles are not oriented the same way. I took this triangle and spun it around, so it's like this. Oriented the same way as this one. I put 47 degrees in the same spot as that right there. Okay, now which of these is the longer side? 30. So over here, since they're similar, I want the longer side right there. Right there. So what's the longer side? 50 and 35. Which is bigger, 50 or 35? I want it right there. 50. So that's why I'm putting 50 right there. 35 would go right there. Now, show that they are similar. All right. This is side angle side, side angle side, side angle side. if these are going to be similar, that means 30 is to 50 as 21 is to 35. We have to show that they are congruent. 30 is to 50 as question mark. 30 is to 50, 21 to 35, 21 to 35. Is that a true statement? 30 is to 50, that's 0.6. 21 divided by 35. 21 divided by 35 equals 0.6. That is also 0.6. They are congruent, so yes, they are similar. It's true. They are similar. Okay? By similar. So the sides are proportional and the angles are congruent. The angles are congruent, so similar by side, angle, side. And our conjecture, a similarity statement is triangle X, X, Y, Z is too easy. Let's go Z, X, Y. Z, X, Y is similar to triangle Z to X to Y. Z, so G, Z to X, Z to X, G to D, G to D, G to D, G to D, G to D. X, Y, X, sorry, Z, X, Y, Z, X, Y, G, D, J. I could do it that way. Or if I said X, Y, Z, X, Y, Z is similar to X, Y, Z, D, J, G. D, J, G. Boom, that's the bottom of the page. All right, so boom, number 25. 25, you have this diagram. And you use a diagram to copy and complete the statement. So if that's 61 by vertical angles are congruent, this is 61. Sign you when it's at night? Don't know that. Are these, don't know that. Are these, they're congruent, but we don't know the angles. Ooh, this triangle here, this triangle here, and this triangle here. These two triangles. And these two triangles. If I take this top triangle and rotate it, like that, so that way. If I rotate it this way, that means that alongside 4, go right there. This 2, biggie the vertical one, that's a 2. And the other side remaining 3.5 would have to go right there. 61 degrees would have to go right there. So here's 61 degrees. And then these two sides match up. These two sides match up. Is this true? 8 is to 4. 8 is to 4 as question mark. Is it equal to 4 over 2? 8 is to 4 as question mark. 4 is to 2. Is that a true statement? That equals 2. That equals 2. Yes, that works. So the sides are proportional. And these angles are congruent. So these two triangles are similar by SAS. Okay. So that means the third side will be proportional. If that's 3.5, 4 times 2 is 8. 2 times 2 is 4. 3.5 times 2 is 7. This would have to be 7. 61 degrees. If that's 61, that's 44. This angle right there, and that angle right there are congruent. If that's 91, that's a straight line, straight angle. So 91 plus this has to equal 180. That's 89, which means this is 89. Hold on. Fix some paper and make this so I can write easier. 89, 61, these three angles have to add up to 180. You can figure out what that angle is. Oh, we're on the way. We're getting there. NSM. 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 We have to figure out for question 25. Find the angle N to S to M. What is that measurement? From N to the letter S to the letter M. N to the S to the M. If that's 89 degrees, what's that measurement? That's going to be 91. Baya, 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 baya. It's 91 degrees. Dink, dink, kadoink. Fin. Ba-boom. Look at that.